Okay, so in this particular problem, it gave you 4 different equations, and then it said try to use at least each method once. I found that when I was looking at these, they were not factorable in the traditional sense. So on most of them, so I only use the averaging of intercepts on one of them, and that is right on this particular one, part C. You'll see where I averaged it right here, plugged it back in, and came up with the vertex. And then the axis of symmetry is x equals 4, so I don't know why that's not next to it, but okay. But I used completing the square on part A, got the vertex, and x equals -3 because that would be the axis of symmetry because it's the x value. And the same thing here, I used completing the square, got the vertex of 2, 5, and the axis of symmetry is x equal 2. The part D was a little trickier, but you just had all the same concepts. You're still doing b over 2 squared, which is 7 over 2, and that squared is 1225. So when you end up doing going through and you end up having a decimal, so your vertex is at -3.5, -14.25, and you can check all of that on the graph too if you want by plugging it in. But that is pretty much what I did for 2-50. I would pause the video if you need more time to look at it, but I wrote them up ahead of time because it would have taken forever to solve all of these, and I probably would have lost half of you on that. So just take a look at what I wrote. If there's one you missed, go back and look at it and correct it and see what you need to do, okay? And that is 2-50. Okay, so the box method was kind of used on this one as an example in the textbook, so I thought I would follow through with it because it'll help with what I've been teaching. But it says represent the number you would have to add to an expression of the form x squared plus bx. In other words, we'd be looking for, so we're used to ax squared plus bx plus c. So if it's x squared plus bx, that's not writing very well. Hang on. If it's x squared plus bx, it means you're missing your c term. And what I've told you on previous videos is that what goes in here is b over 2 squared. But we can prove that here. So let's use this box method. So x times x is x squared, okay? And then x times b over 2 is b over 2x. And b over 2x, right? Well, then your c term is b over 2 squared. So if I took that out, it would be x squared, right? Plus, we would add those together. That would just be bx, right? Because we'd have 2bx over 2, which the 2's would cancel, okay? Then you would have plus b over 2 squared. And so that helps explain why I've been doing that with completing the square and showing you how you come to that answer. Okay, that is 2-51. Moving on. So the question was, what's the difference between y equals 2 to the x and y equals -2 to the x? Well, similar to if you have a negative coefficient on a quadratic where it changes the direction and flips it upside down, it reflects it over the x-axis for the parent function. Same thing happens here. We have y equals 2 to the x, and when you add the negative in front of it, it reflects over the x-axis. So they're a reflection of each other over the x-axis. And that is all there is to 2-52. Okay, so this particular problem, they give you the lines, or they actually give you the points. In this case, it is, I kind of did each one of these a little different, -2 and 4, and then 4, 7. And then over here, you see them on the actual graph. But on the first one, what I did is I graphed the points, and then I created a right triangle and figured out my rise over my run. So my slope is 3/6 or 1/2. Then I did the Pythagorean theorem to get, because you want the length of the hypotenuse. So I found that the distance of the line actually is not necessarily the length of the hypotenuse. That's just what we actually ended up finding. But then because I had the slope, I used the point of 4, 7 and the slope, and I calculated for b by plugging in the 7 and the 4. And then I came up with my equation. So this is the equation of the line for part A. Part B is pretty simple. They're on a vertical, and it's, first of all, it's not a function, so we can't say f of x equals, but it is a line. It is x equals 3. And so the distance, though, you could also just count like I did. You could say 4 minus a negative 1, because that's actually the distance, but it ends up being a positive 5, and you can actually count that. So 1, 2, 3, 4, 5. Pretty easy to do on that one. Okay, let's move to the next one. Okay, so for part C, move that in a little bit more. For part C, you will see that I have this line segment, which is fine, but I didn't want to sit there and count and go, okay, 1, 2, I didn't want to go through here and count all of this to figure out what those are. So I just used the distance formula, which you'll see set up here. So I used x1 minus x2 squared plus y1 minus y2 squared, which got me down to 5 root 5. So that's the length of the segment there. Then what I did is I calculated slope by using the 2 points. I used the slope formula. It gave me a negative 3/2, which makes sense because this is pointing down in a negative direction. Then I picked the point of 20 and negative 7, plugged it into the y equals mx plus b formula to solve for my y-intercept, which ended up being 19 over 2. And so my equation is y equals negative 3/2 x plus 19 over 2. Part D ended up being pretty easy also, kind of like part B, only this time it's a horizontal line segment. And it can be a function because it passes the vertical line test. And horizontal lines do have a slope of 0. So all I'm doing is a horizontal line equation of y equals negative 2. And if you look, I also just counted 1, 2, 3, 4. I didn't have to do anything else for that to figure out the length of the segment. Okay, and that ends 2-53. So this one wants us to use the quadratic formula, which we will. But what I want to do first is we have a cubic equation. So the first thing I need to do is factor out an x from each, from all of those. So I'm just going to write the equation out again here. Okay. So 4x to the third plus 23x squared minus 2x equals 0. So I'm just going to take an x out, and then that'll give me a quadratic that I can use in the quadratic formula. So now it's 4x squared plus 23x minus 2. Okay. This will be x equals 0. Okay, because that's the only thing that it could be. And then what I'm going to do is take the rest of the information and plug it in to the quadratic formula, which you'll see I have listed right here. Okay, so let's get another pen color for that. So x is going to equal, and it says negative b, so it's a negative 23 plus or minus the 23 squared minus 4 times a, which is 4, times c, which is a negative 2, all over 2 times 4. Okay, let's break that down a little farther. So when I do the math underneath the radical, we end up with a negative 23 plus or minus, and that is 529 plus 32. I could probably get rid of a little bit of this little tail here. We don't need all of that. And then it's all over 8. So we have one more step because it's x equals negative 23 plus or minus square root of 561 all over 8. Okay, so that's 2 of the zeros, or x equals 0. And you can't break down the square root of 561, so that is just your final answer. Those are the 3 possible zeros, the actual 3 zeros for 2-54. Moving on. Okay, so this particular problem asks you to solve for x in each of these diagrams. And so what you see I'm doing here is I have already solved using the Pythagorean theorem for both A and for B. Okay, that's all you need. And I left them in exact form. I did not do this in decimal. I ended up going in exact form, so simplifying the radical. Okay, If you want to, you can type that in the calculator and figure out what the decimal is. But at this point, that was what was important to me to keep it exact. I think it's like 22.4 if you're looking for the decimal. All right. On part C, it's actually easy if you look at the diagram, okay? This particular triangle, and I will delete that in a minute, that particular triangle is a special triangle. It's 45, 45, 90. So with that information, I know that this side is 25, and I know that this is 25, okay? And that's because of the properties of a 45, 45, 90. So 45, 45, 90, if you remember, I'm sorry, that triangle's not beautiful. The legs are, this is just the ratio, and then the x root 2, okay? So that's how I know that the legs are 25 on that one. On a 30, 60, 90 triangle, we have 30 degrees, 60, and we have x. And the ratios for that are opposite the 30 is x. The hypotenuse is twice the value of opposite the 30, so it's 2x. And then the side opposite the 60 is to x times root 3. What's nice on this one is once I have this 25, do I get a different color here? Oh, I didn't get a different color, sorry. Different color here. It means that my x equals 2 times that, so my x is 50. So x on this one equals 50 because of the properties of a special triangle. And just to break it down a little bit more, I'll get rid of this and just say that these two are part of the drawing above, just so you can see it a little more clearly. I'm going to put a 25 here because that's what's opposite my 30. That means my hypotenuse has to be 50. But that also means that this would be 25 root 3. Okay? That ends 2-55, and we're moving on. Okay, so this particular problem wants to know, it says a dart hits each of these dartboards at random. What is the probability that the dart will land in the unshaded area? So the first one's pretty easy because we're just going to take the unshaded area, which is the smaller circle. Let me kind of underline this stuff as I go. Okay, good. All right. So the unshaded circle is going to be the area of 4 pi. Okay. Then we're going to take the entire circle, which is the radius is 4, so it's going to be 16 pi because it's 4 squared. All right. And so then to figure out the odds or the probability that it lands in unshaded area, sorry for my minion talking in the background. I'm going to put 4 pi over 16 pi, which reduces to 1/4. So 1/4 is the probability that a dart will hit the unshaded area on that one. Now on the next one, I'm going to take the center of the circle, which is 2, the radius is 2, so that means it's 4 pi. Then I'm going to take the center and unshaded, so basically from here to here. And so that gives me 16 pi, which is similar to the last circle that we were doing. Well, then I'm subtracting 16 minus 4 because that little inside is shaded, okay? So, and I want the unshaded area, so that's 12 pi. Then I've got the whole circle, and when I take the whole circle, the radius is 6, so the whole circle's area is going to be 36 pi. Well, then I put probability lands in unshaded area, that is 12 pi over 36 pi, which just equals 1/3. So that's the answer for part B. And that answers 2-56. Okay, so on this particular one, when it says you can, it's got, if 2/3 of A is 5 over 12, well, that's an equation, okay? 2/3 A equals 5/12, so I'm setting that equation up. And then it says, and 4/3 of B is 8 over 9. So I'm setting up an equation for that to solve for B. So let's solve for A first. So to get rid of the 2/3, I'm literally going to multiply both sides of the equations by 3 over 2, because that means I can cancel those, and that just leaves it as A. But then I've got to multiply this side by 3 over 2. So that becomes 15 over 24, okay? So that's A. Now on the right side, so I'm not going to do anything. I could reduce it right now, but I just want to see what's going on this other one first. So again, same thing. I'm going to flip by the inverse of 4/3. I'm going to multiply by the inverse of 4/3, sorry. Multiply by 3 over 4, and I can cancel those out, okay? But multiply this by 3 over 4 as well. And so B will equal 24 over 36. Okay, so now what I'm going to do is I'm going to reduce the fractions just to see what's going on here. So I can reduce each of these down to, or this one down to the third. All right, so there's 5/8 when I reduce that. And by the way, there's a really cool tool. If you put this into the Texas Instrument calculator and you type the fraction but don't hit enter, then you hit the math button and then the fraction button, hit enter, it'll simplify it for you. So if you need to hear that tip, just rewind it a little bit more and try it. But that's 5/8. I'm hoping that most of you can just go ahead and do it on your own without worrying about it. Okay. And so then part B ends up being 2/3. So which one is greater? Can you tell from looking at it? Maybe not. So I think what I'm going to do now is go for the common denominator on these. And I'm going to, the first one that both 8 and 3 go into is 24. So I'm going to take this one back up to 15/24. But then I'm going to multiply this by 8/8 because that gets the denominator to a 24. And that equals 16/24. So B is actually larger. All right, I hope that helped. Okay, so if you use the activities, so this is 2-5/8, and it says examine the diagram at the right. In this case, it's below. Imagine spinning the rectangle around the y-axis. Think of a rectangular flap attached to the y-axis so that the rectangle will revolve around the y-axis. So that, if you look at that, creates a cylinder. And that's what I have here. That's an image of what happens if you use the E tool that they gave you for this particular problem. So then you just have to look at the information. And this is the equation for the volume of a cylinder. And so we just have to figure out the information. So the first thing I have is volume equals pi. We're not changing pi. Our radius is from here to here. And so that is 3 squared, okay? And then our height, if you're careful and look at the scale, the height is 5. So then that means I'm going to have volume equals, and I'm going to go ahead and 3 squared is 9 times 5, so that's 45 pi. Now, if you multiply that out to a decimal, it will take you out to 141.37 units. And remember, this is volume, so it has to be cubed. So 141.37, round to the nearest hundredth, units cubed. And that is your answer for 2-5/8. So on 2-59, it asks us to talk about lines of symmetry and draw some shapes that have a line of symmetry. So I'm going to go ahead and pop up this little video that shows you the lines of symmetry for different shapes. So the perfect shape for one that has exactly one line of symmetry is an isosceles triangle. And you can see that because we have our line of symmetry that goes down the middle, and there's no line of symmetry on any other side. Again, that's an isosceles triangle. If it was an equilateral triangle, we would have 3 lines of symmetry. Now I'm going to mute that, and then we're going to bring up one that has exactly 2 lines of symmetry. And you have this one right here where it's showing the 2 lines of symmetry. You would also have 2 lines of symmetry in a rectangle. So it's just kind of depends on the shape, but those are exactly 2, in that there are many shapes that have more, but this one is asking for exactly 2. And that is the diamond, or a parallelogram, or a rectangle, okay? And then the last one, hopefully you were able to figure this one out. This shape has an infinite number of lines of symmetry, and you'll see that it just makes complete sense. I could sit here and drag this little circle all the way around, and it's not stopping at any point. It's an infinite number of, is it going to let me go around this way? Yes. It's an infinite number of points or lines of symmetry that cross through the middle. It's not letting me go all the way around very easily. My mouse is apparently not liking it very much, but that's okay. You get the picture. And so that will answer 2-59, and we're moving on. Okay, so on 2-60, it says find the point where these 2 lines intersect. So I already have a situation where this particular equation is set equal to y. So I just substitute the 3x minus 1 into the y of the second equation. That way I can solve down to where x equals 5. then I in turn plug it into the equation of the first equation that I used for substitution. I solve for 14. Okay, so the solution is the 0.514. That's where they would intersect. And here is an image of the graph where they do intersect at 514. Okay, hope that helps. That is 2-60, and moving on. Okay, on this particular problem, you set it up. So what you'll see here is that I defined X as the number of hours that Letty drives. Letty just got her driver's license. Her friends soon nicknamed her Leadfoot because she is always going 80 miles an hour on the freeway, even though the speed limit is 65. So at this speed, at this speed, how long will it take her to travel 50 miles? You will see that I set up an equation and solved for X, and it will take 0.625 hours for her to travel 50 miles at the speed of 80 miles an hour. Well, then on B, it says, how long would it take her if she drove the 50 miles at 65 miles an hour? Same thing, set up an equation, 65x equals 50. You get down to 0.769, which you could round to 0.77, which I did in the next part of the equation, which tells you that it takes about 0.77 hours to get there if you're driving the speed limit. Well, then it said speeding tickets carry fines of about $200 and usually increase the cost of insurance. If Letty gets a ticket on this trip, then what would be her cost per minute of time saved? So that's where you see this, the time saved. This is the actual of 0.77 if you're following the speed limit. This is what she did at 80 miles an hour. So I'm subtracting those. So 200 divided by the difference between the actual and the time it took her is 1379.31. Okay, now that is the amount of money if you do that. But then you divide it by minutes. So by 60 minutes, I took $1,379.31 and divided it by 60 minutes. So the cost per minute of time saved would be at $22.99 per minute. So almost $23 per minute for her going over the speed limit. Not sure it's worth it. So anyway, that ends 2-61. So as I said on the first video, I am working through a lot of these problems ahead of time, just because there's so many. And then on the ones that I think we need some extra work, I will do those individually. But on this one, it should be review. All of this should be review for you. So I'm going to go through it and we'll talk about it as I go. And on part A, because that's where we're at right now, I just did the Pythagorean theorem. It says it wants the exact answer, and there's no way to break down a square root of 61, so that's why it's the answer. On part B, you end up figuring out, and you could figure it out just from looking at it anyway, but this is a special triangle. So when I do the sign, and this is a C, even though it doesn't look like it, equals 3/6, that is 1/2. You could put 1/2 in these parentheses, or you could just leave it as 3/6. But because I'm looking for an angle measure, I'm looking for angle C, I have to use the inverse function. So set a sine. So on the calculator, you'd say second sine 3/6 equals the measure of angle C, which is 30, which means this is a special triangle. And so in addition to the work that you're just doing to prove that, you've got a 30, and then this is a 60. So let me erase those. Just too much ink stuff getting in the way there. All right, so this is a 30, 60, 90 triangle, okay? So that means this side, if you were actually having to solve it, would be 3√3, if you know your properties of simple or special triangles. All right, part C, again, it wants an exact answer. So you'll see what I did here. I used tangent because it wants the measure of angle B, so that's the opposite over the adjacent. But again, I have to use the inverse tangent to find the angle measure. Well, that turns out to be 38.7 degrees when you round it. But this particular problem wants it in exact form. So I have to put this actual part of the equation in as my answer because that is exact, whereas 38.7 degrees is not exact. So you're taking the equation. On part D, I simply know because they give us 30 and 90 that this is 60 degrees right here. But that also tells me I have a special triangle. So I know my hypotenuse is 10. I know that opposite the 30 is half of the hypotenuse. And then I know that adjacent to the 30 is going to be the smallest side of 5 times √3. So that's why my answer is 5 root 3 on that particular problem. And that ends 2-62. Okay, on 2-63, it says below are two situations that can be described using exponential functions. They represent a small sampling of the situations where quantities grow or decay by a constant percentage over equal periods of time. For each situation, let's find an appropriate unit of time and find a multiplier and identify the initial value, then write an equation. But the equation, this f of x, I want to break it down a little bit more, equals a times, it's 1 plus our rate, okay? And so then it's to the x in this case. A lot of times you'll see it to the t because it's usually referring to time, and t is also a variable on your calculator if you look at the x button. But this represents, if it's plus r, meaning we have a positive, it's going to be a growth situation. If we do minus r, that means we have a decay situation. Both of these equations both of these situations will be growth situations. So on the first part, we have a house purchased for $120,000. Well, that is our starting point. Okay, and then it's growing at 6%, so it's going to be 1.06 as our multiplier. And then, of course, it's going to be to the x. That's the equation. And the appropriate unit of time for this one is years. So that's what that's what the x will represent. X equals number of years, okay? And that is the appropriate unit of time for that particular situation because it does say annual, okay? That takes care of part A. Part B, the number of bacteria present in a colony is 180. So there's our starting point. Okay, and our multiplier, it says it increases at a rate of 22%. So that is going to be 1 plus 0.22 raised to the x. So if we're taking our full equation down, it is f of x equals 180 times 1.22 to the x. And the x in this case is number of hours. So again, it has an element of time to it. And so that is all there is to this particular problem. And thank you so much. That's the last problem in this review and preview. So if you enjoyed this video or you learned something from this video, which is even more important because I know some of you may not be enjoying math, but please give us a thumbs up. And at the same time, if you want, go ahead and subscribe. That way you get all of the videos. And last but not least, if you have questions about any of the math, go ahead and put them in the comments section of the video, and then I will get back to you. So thanks again, and we'll see you on the next video.